these are actions from the chatbot, right? Any questions? Any points here? Okay. So what are some of the things we studied last time or kind of covered last time? Some of these have not been covered. Some of these will be covered as we go on, right? So identifying intent can be done in multiple ways. There is this regex based approach, right? I'll show you a simple chatbot today on where a regex based approach works, right? It's a popular one, and it's some a tool which all of you might have used earlier. And then there is the similarity match approach as well, cosine distance. Now this is a huge topic in itself. Similarity match is a simple comparison, right? Sorry, yes, similarity match is basically comparing two text entries, right? And it can be done in multiple ways. I'm just saying cosine, but as you know, there are multiple ways you can convert into a word vector and then kind of compare things, right? Or you can convert by using any other model as well, right? Now the other approach is ML model approach, which also we were trying last time, if you remember. We were trying to train. I mean, we had intent on the predicted side, and on the input side we had the free text, right? So that's the ML model approach. You want to predict what's the intent. And also there are now state of the art methods, very recent methods. So as we all know, transformers from the last 3 or 4 years has totally revolutionized the natural language processing field. So we have these zero shot model, transformer based models, other things here, right? That's like in a nutshell some of these methods which are there. We will do hands-on sessions today. I will spend almost half the session today, half the class today on doing hands-on, right? So so these are some of the user intent identification base, right? Can somebody tell me what all we had done last time in terms of user identification or intent identification? Just a quick recap. I'm hoping people still remember what was covered in the last class.
We covered that zero shot classification.
Yeah. Okay. That's good. So zero shot model was one of the things. Then we also covered that the same thing can be done by training an ML model as well, right? So our data set was the Reva data set. I think Noor, did you share that data set if I remember correctly?
It was Pravina who shared.
Pravina shared. Okay. So is she already in the class?
So
No.
Pravina's on leave.
Okay, Pravina's on leave. Okay. So I hope we have access to that data set today, right? It was shared with the class, so I think we'll have it, right? I think, yeah, it was shared with the class on the mail, so I think we'll still have it if we need it. Okay. So yeah, so we also, the other approach we took was the ML model approach, where even though the data set was less, the approach is very good when you have enough data set, enough data points, and you want to train the model, giving it on one side the questions, right? Or the kind of, yeah, the kind of questions you are asking or is expected, and on the other side the intent of the question, right? So when somebody asks any question which is of a similar intent, the machine learning model is supposed to identify it, right? The state of the art model will not, a zero shot model, the reason I introduced it was because it's a really powerful tool and it's being used a lot in the industry. In fact, I had recently met a very senior person, a very accomplished person from the industry. He's a Kaggle grandmaster, quadruple Kaggle grandmaster. His name is SRK. Some of you might have heard of his name, Sudlai Rajkumar, right? So I was talking to him, and we were discussing what are some of the important things in NLP which he likes, and he said it's zero shot model, right? So zero shot model is a really powerful concept. And that's the reason why I covered it in the first class, where we can use it for a lot of things. It's just one of the applications where you can identify the intent as well, right? By the way, any questions on zero shot model? Some of you mentioned that you'll be trying it for some other projects as well. Did you try it? Did you see how it, I mean, how it helps you? Any
Ravi?
views there?
Yes, yes, sir. I have tried for automobile identifying the brand name and the
Uh-huh.
model name of the car, as well as
Okay.
extracting some kind of numbers from the context. So I was able to get, but initially I was not able to get properly. But I fine-tuned the question, then I was able to get almost close answers, sir.
Okay.
It's
So
really
so
powerful, actually.
yes. So I mean, if I understood you correctly, you are trying to build a chatbot kind of application for automobile domain, right?
Not chatbot exactly, sir. Actually, what happens is
Hmm.
they will want to add the items in the platform. So what they
Mm-hmm.
do is they add a description. So we need to, using the description, we need to populate all other information like brand, what is the model of that car, and also the what is the horsepower of that car, and what type of the vehicle it is. It's a hatchback or SUV, or all those information is present in the description. You have to
Mm-hmm.
extract those information and populate other fields. So I have asked the different questions like what is the car model type, and what is the car, who are the
So
car manufacturer, all
I
this
think
question.
I think you're using the Q&A model, right?
Yes,
Uh,
yes. Yeah,
Okay.
pipeline, sir. Sorry, I maybe
Yeah.
not a zero shot model. Pipeline,
Yeah,
yes.
yeah. Okay, okay. So yeah, so no. So then no, that's also a powerful model. In fact, why I am not mentioning it here is actually Q&A is a different application, but you can use it for answering the questions as well, right? But typically, the way a Q&A is implemented is different from a chatbot, right? A chatbot involves all those steps. If you remember from the slide last time, I said there is a dialogue state tracker, and then based on whatever policy you are following, there will be a response. I will kind of share, I mean, just recap that whole flow again. But a Q&A model is also can also be used for answering questions, but the way it works is different. Q&A model has been trained on the input side. And Q&A model, you have this question, right? And on the output side, a text or a passage, the answer to the question has been marked. So the answer is in the form of, okay, it starts from the fifth character and goes till the 25th character, 20 characters long, right? So this is the way it has been trained. So it is good at identifying exactly the location within kind of text where the answer is. There is another kind of question answering model which I have not covered, right? The last time which I had covered, if you remember, was extractive question answer model. Why is it called extractive? Can this somebody remember? I might have told in the class, I'm sure. Why is it called an extractive Q&A? Okay, so the reason it's called extractive because it is extracting the answer from a passage, right? So if you remember, we took Mysore text from Wikipedia, right? And then we asked question, where is Mysore located? And it was able to identify within the text the answer portion. Do you remember?
Yes, sir.
Okay, so
Yeah.
that is why it is called an extractive Q&A model, right? Because it's extracting from existing text. It cannot answer your question. So for example, if we share something about Mysore's location and we ask what is the Mysore weather like, it will not be able to answer because that answer is not there. It will give you some text, but it will give you a confidence score which is very low, right? Those are some of the limitations. But yeah, I agree, it's really powerful tool. Any other I mean, anybody else who wants to share any use case which you think of? Both these things can be useful as zero shot or a Q&A model. Okay, by the way, we'll be
They
also.
also tried for zero shot model for identifying the categorization, sir. But I
Mhm.
have faced some issue. There was some category name. They have maybe around 1,000, I guess. I
Mm.
did not recollect, but in my case, had a lot of categories, so I could not able to proceed further.
Okay, see, when you say 1,000 categories, okay, can you give me 1 second please? I have just one phone call is coming. Just
Sure,
1 second
sure,
please.
sure.
class. Somebody was continuously ringing, so I had to take the call. Okay, sorry, what were we discussing? You had like 1,000 entries, correct? 1,000 labels?
Around 100 or 1,000, maybe 1,000, sir. I forgot the actual count, but I tried for the lot many categories. So
Mhm.
it was throwing error like cannot proceed. Something I was getting error, so I stopped
Okay.
exploring.
So here is a suggestion. So 1,000 labels is actually too much. I have tried at most with 70 labels. Okay, 70, 75. Yeah. So the moment you have too many labels, what you are asking the model to do is compare each of these 70 labels with the text and find out which is the closest. Right? It is generating score for everything. So it makes it slightly slow, but 1,000 is actually too much. So what kind of labels are you looking at actually? Can you share with us so that maybe I can suggest something where you can group those labels?
Uh, sure, sir. Actually, I have a kind of data set, automobile data set, sir. Like
Hmm.
we have amplifiers or many categories. And
Hmm.
so let me see anything I have data.
Yeah, because see, identifying any kind of categories in text, if you become good at it, if you solve that problem, then you are also it'll also work out for a conversational agent, because conversational agent, the key idea behind conversational agent is you need to understand what the user is typing, right? So any of these
Yes,
problems
sir.
which you are solving, it is kind of making you an expert in this domain as well.
Yes. So shall I share my screen?
Yes, go ahead, I will unshare.
I have shared my screen. Able to see?
Yes, I can see. Just a minute, let me.
Okay, so like this, we have a product descriptions, lot many here. Based on this, I need to identify it's what type of category it is. It's
Okay,
amplifier.
you are in luck. I recently solved a very similar issue with computer parts.
Oh,
So
okay.
yes, so
It's automobile industries.
yeah.
It's yeah. So they have well, very large set of categories. So
So
this,
one, sorry, okay, this is so class. This is an important problem, very relevant to the conversational agent. Why is that? Because you have this free text, which is a product description, right? And you want to label it as the type of equipment. So amplifier can be of these three types or maybe more, what you see on the screen. Then you have mass airflow meter sensors. Now, why is it slightly challenging? Because this is like a part detail, right? You have a part description, 174 horsepower SUV, 5 doors automatic, right? Not all of those are relevant to the part type, maybe, right? But that's
yes,
what makes it challenging. Go ahead.
yes, sir. Like this, like I tried for some categories, so it's
Hmm.
could not able to. I was not able to get the
So I would
answers, but
I
I
would
limited. I tried for around 10, 20. I have tried. I was able to get um, mm, the decent score, but when I add everything, so it was like I
do
was
you
not able
have
to.
okay, so here is an approach, right? Do you have these labels noted in one place? So see, why I was saying that is, maybe you can, these labels, how many unique labels you have? Probably you're saying 1,000, is that correct?
Yeah, more than yes, sir. Yes, and it'll go on
So
increase, sir.
I
This
I would
is
I would recommend, see again, maybe okay, if you want to use zero shot, we can definitely work on that. But probably, have you tried first? Even a machine learning model will face issues, because you have this problem where there the labels to be predicted, or the output variable is target. It's called a target variable, right? It's like
correct.
huge.
Yes,
So
sir. Yeah.
so if you run a machine learning model on this, it will suffer, right? It will not
Yes, sir.
be. It
Correct,
will
sir.
not.
We are facing
Yeah.
that currently.
Okay.
So
So
yeah,
to
we
reduce
have.
that, you need to reduce the number of variables to be predicted. So one way to do it is, you can, so for example, amplifier looks very simple. Amplifier is just amplifier, right? But maybe your mass airflow meter sensor is one sensor. You can have other sensors as well, right? So you need to first create these higher level categories, okay, which are maybe just sensors, and sensors can be of 50 different types, but you don't care as of now. So sensors is one category, amplifier is one category, then probably a suspension is another category. I'm just guessing, right? So
Okay.
these maybe 15, 20, 30 categories at the top. You first predict those. Then within a sensor, you might have 20 different other categories or 50 different categories. Then you run a model again for that.
Okay.
So kind of a, I would say, a hierarchical approach, right? Hierarchy.
Mm-hmm.
First sensor, then within sensor maybe 20 other things or 50 other
Mm-hmm.
things, right? So that's the approach which should work for you, which is one suggested
Okay.
approach. Something similar I have done for a similar problem in the past.
Okay, sir. Okay. So once I get the top layer category, then again the same model can I run for to identifying the sub level, sir? That can be done.
Yes. So I'm saying maybe let's not see again. Let's not try to solve something with because we. I mean, zero shot model is a very powerful model, but maybe there is something simpler which also works here, right? So maybe for a sensor it works. Now within a sensor you can again train a model for 50 categories. Simple
Okay.
model first. So start with a simple machine learning model. Then
Okay.
see if the zero shot model can help you. So for example, the first level sensor amplifier, right? That definitely a zero shot model will be able to help you. it'll be
Okay,
it'll
sir.
be telling you, okay, is this a sensor kind of thing? It's like, I mean, this kind of thing, right? But after that probably you can train it, right? So
Yeah,
definitely whatever approach you take, it should be based on the output you see, but definitely reduce the number of targets here.
got it, sir. Thank you. Sir, and also
Okay.
the one more challenge I have here, sir. This is the reselling platform. So the now currently we have a customer automobile BMW or Audi and all coming as a
Mhm,
part of customer now. So it's a
mhm,
kind of automobile data sets. In the
mhm,
future, maybe Dell, HP or other customer will come to resell
mhm.
their parts. On that time, again, we how do we do like the same model again? We need to retrain for many huge data sets. Right now, we have automobile data set. On top of that, again, we will have a system data set. So we need to have a separate the model for all this, or how do we tackle this kind of problem, sir?
Okay, so that's an interesting point. Maybe we can connect offline as well, but
Sure, sir.
there is a way where you can build a model. I was recently working on something similar. Again, not the same domain, right? Where it will take this huge description you have and just keep the very important portions of it. So for example, maybe that on the top line, whatever you have, right, in the end, 7L6035 577C is not that important for classification because that's not
Mhm.
adding value probably, right? So that's just like identifying what specific part it is, right? But the
Correct, sir.
type of part maybe just the first 3 4 words, right? Antenna
Mm.
booster for Mercedes Benz G class. Maybe that's just the important thing. So need to identify the important thing only, and just so in future when new entries come, this technique which you have developed will clean it up and just bundle it. Okay, existing we have boosters. Maybe this is also a booster. Let's just keep it in the booster. Okay.
Okay.
So again, this is
Sure.
relevant to a NLP problem and relevant to conversational AI as well, because you are identifying the type of part. In conversational AI, similar techniques will be used to identify intent. Okay,
Okay, sir. Thank
thank
you,
you.
sir.
So this was, sorry, this was Santosh who was sharing screen.
Mm. Yes, sir.
Okay, thanks, Santosh. So anybody else? So I started the lesson, but I really wanted to have discussion so that we have this. I mean, I am assured that you are understanding what I'm trying to cover. Any other points? Any other discussion points before we go back to the slides?
Sir, one request. Uh,
Sure.
when I try the name base, etc., on the given data set, accuracy
Ah,
is very low. So can we choose some other data set which is
sure, Soumya. So if you remember, I said that please expect low accuracy because it's
yeah,
like a what was the count? 72. What is the total count of the data? Sorry, I
uh,
don't remember.
just a minute,
Uh,
sir. Let me
no,
check.
I mean less than 200, right? If I remember correctly.
Yes, it is less than 200.
So
It's like
see, all of you would be, I mean, would agree with me that 200 for any model, naive Bayes or any other model, will be too less. So okay, one good point. Thanks, Soumya, for bringing this up. Right, when you have very little data and you cannot train a model, zero shot model is the first approach you should take. That's definitely the first approach in such situations. Okay, you were saying something, Soumya?
No, I was just echoing you. The size was 140, and if we drop the NAs, the size reduces to 138. So it's even less than 200. So
Correct. We will find this today. Actually, I have like in a half an hour or so, I have this entity extraction exercise for the class. Okay, which is I would share with you a kind of a guide as well, where it is shown how to do it. But that's something I really want the class to be expert in, right? So the idea, I will just cover that idea, and that's something which we will see. That data set which I have can probably be used for this exercise as well, the naive based training one, so we can try that. Okay.
thank you, sir.
Okay, and thanks, Soumya. Any other points, discussions? Okay, just a second. I'll share again, but I just wanted to. Let's. I think. So Noor is in the class, right? Noor?
Yes,
No,
sir.
I don't. Yeah, you're there. Okay, great. Purnima is there. Pravina is not there. Ritvik there?
Sir, Ritvik will be joining at 11.
Okay, cool. Santosh is there. Shivpriya is there. Then Swami Srivastav is there. Vara Prasad, you are there. I can see you. Vinay is there, right? Vinay just joined, I think. Correct? Hey, Vinay, are you there? Okay, I remember seeing Vinay in the lobby, so not sure. Probably he dropped. Yeah, so Kartireshan, you're there, correct?
Yeah, I'm here, sir.
Okay. Good morning.
Good morning.
Ashutosh and Sri Hari, are you there, both of you?
Sir, Ashutosh will also be joining at 11.
Okay, cool. So Shri and Sri Hari. Okay, I think Sri Hari is not there. Anybody's name who I missed? Okay, so that's good. So let me start sharing again. We reach an interesting point in the discussion. Can you see my? Just once again. Yeah. I hope you can see my screen.
Yes.
Okay, let me go to slideshow mode again. Okay, so this was I mean, some of the approaches we can take, and they all come with their own set of advantages and disadvantages, right? But again, depending on the business use case, you can choose which one works best. So let's move to the next slide. Okay, so this is something called, okay, so before I go here, see, if I ask you a question, and this is, I've taken the president of US, Joe Biden, right? So how do, if I ask you who is Joe Biden, what is your answer? I mean, anybody, you can kind of give me the answer. I'm just trying to explain a important concept here.
The president of US.
President of US, right? That's your answer, right? So how do you know it, Soumya? You have read about it. You have seen it on TV.
Yes.
Okay, so you actually have knowledge about it, right? there is some knowledge, correct?
Correct.
Okay. Now, so you are a human being. We all are human beings, right? For us, it's knowledge based. So when you ask machine this question, right? From the first class, from the last session, we remember for the Reva questionnaire, right? We had this repository of questions and intents, right? Intents we created by combining category and subcategory. You remember, right? So that was kind of a knowledge base, right? That was kind of our data set, correct? Okay. Now, if so, we all know there are a lot of knowledge sources in the world, right? I'm sure all of you use Wikipedia, correct? So,
Yes.
so Wikipedia is a knowledge source as well, right? So, what is the benefit, or when you have these questions, right? Like who is Joe Biden, right? Now, there are other questions related to Joe Biden as well, right? For us humans, it is very easy to answer when you read a Wikipedia article on Joe Biden, right? So, for example, if I open the browser, if I type Joe Biden and I go to his Wikipedia page, so I'll just say Joseph Biden Jr. is an American politician who is 46th and current president of the United States, right? So the moment the first paragraph you read, you can now you have information now on other questions as well, right? So the question here, if I ask, who is the 46th president of USA, right? The answer is right here. It's Joe Biden, right? Now this is something which this knowledge base has a lot of this information. So if a chatbot is being asked questions related to maybe of entity, right? Don't you think a knowledge base is an important source from where you can get the information, right? Now there is an important difference. We as humans are actually making that connection, and we also remember, and somebody asks us a question, we can quickly go to the Wikipedia page and extract that information. How are we extracting it? We are reading this line. So we will say, we can probably say, okay, somebody is asking me 46th. So let me check. Oh, by the way, that is not how we will check for 46. We will simply Google for it, right? That is different. But yeah, we can just read the article and we know after reading this, okay, this is 46. Now, is it as simple for the machine? How will a machine find all this, right? The machines unfortunately cannot read or understand like us, right? All of you agree? Especially, I mean, till now, of course, maybe in future, somebody makes like a fully, I mean, completely, what is that called? Artificial general intelligence, AGI, right? That then it's different, right? Not sure when it will happen, but right now it doesn't understand like this, right? So how will you teach machine or make it easier for the machine to know these facts? Any suggestions, anyone? You got my question, right? What am I saying? What am I asking you?
Yes, sir.
So we can read this. He defeated John McCain and running mate Sarah Palin in. They were re-elected in 2012, right? All these questions you get, you're reading it. How will you make it easy for a machine so that when you ask a question, who was the president when Biden was a vice president, right? So that you are able to answer. A machine is able to answer that question. How will you represent this? How will you represent all this? That's the question. Any suggestions? See, again, this is a design problem. It's not something which, I mean, whatever solution I will be showing you is one of the 10 solutions. So please let me know what are your thoughts.
Ravi sir, we can think of one structure, say whatever important entities we need. For example, for president,
Mhm.
these entities should be known, like date of birth or the colleagues, etc. And then for this particular data set of Joe Biden, we can try to fetch those details for the sub entities. I mean, we have that structure in place.
Eh, yeah, go ahead, go ahead. Sorry. Yeah.
And so we have that structure in place, and with over time we can refine that structure that currently we are looking for Joe Biden, and the structure is fulfilling the whatever details we need, and if we need are missing some sub entity, we can add that in future.
That's a great point. Thank you, Swami. So that is general approach is we never know what question might be asked, right? It is not fixed. If I give a Joe Biden article, it's a knowledge base. There are a lot of questions here. Okay. By the way, on a side note, just sharing with the class here, just like there is a Q&A model, there is a reverse model as well. You can find it out. I will share it with you on like today sometime, just as a knowledge, as a side information useful. If you give it an answer, it will give you the question, right? Has anybody used that model where you give an answer and it will give you the question for that answer? Uh, Nobody has used that question, that model. It's called a question model. It generates questions for free text. Okay, that's an interesting one. You can have a look at that as well. Okay. So yeah, Swami, as I was saying, this is a good approach. So we can. So in general, what the approach we take is okay. Before we do that, any other points from the class?
And maybe it's like we given any article, maybe we can
Uh,
have a kind of set of question and answers, FAQs kind of thing, and
mhm.
that based on that, and next whenever questions come, similar, if the matching question is there, the same answer can be reverted.
Again, that's also a valid suggestion actually. So you can see in that one challenge there is how who will sit and draw those questions. Sorry, write those questions, right?
Yeah, correct.
So I just gave you the answer for that as well. There is a model which takes your text and generates questions. So that's one approach. But again, you have this. It is challenging in the sense that I don't know what how accurate that model might be. Might not work very nicely on maybe complex text. We never know, right? I've not used it a lot. But again, the problem is the manual compilation, right? Manual compilation of questions. So FAQ creation might be manual unless you have a model for doing that. But again, it's a valid suggestion where you have reduced this text into a bunch of questions and answers. Okay. So that's okay. Great points actually, both by Soumya and Santosh. Any other kind of suggestions here, or if you all agree with it? Okay, so I think yeah. So I think both the suggestions were pretty logical, right? So let me tell you what is typically done. Uh, can you see the slide now?
Yes, sir.
Yes, sir.
Yes.
I actually. Okay, is it okay if I keep it in this mode and not slideshow? Is it visible? Fine.
Yes, sir. That's
Yes,
fine.
sir. Yeah.
Okay. Okay. Let me know if it's not visible because yeah. So then okay. So these are some of the maybe I'll call it attributes. Okay, attribute word or feature word for this entity Joe Biden, who is the president of USA. So he was born in 1942. He was born in Pennsylvania. His spouse is Jill Biden. His children, one of the children is Hunter Biden as well, right? Other children as well, but I've just noted one kid's name here or child's name here. So if you draw this as maybe visually, if you want to depict it, Joe Biden is an entity. Pennsylvania is a place, is another entity. Jill Biden is an entity. Hunter Biden is an entity, and all these entities are related to each other, right? Related, have some connections. So I will not be covering graph theory, but I'm assuming some of you might have heard of graph AI. Have you heard of it?
Sorry, can you please repeat?
Okay, so graph AI, graph artificial intelligence, have you heard of that before? Graph AI.
No,
Okay.
sir.
So, sir.
Okay. Okay. So here is, I will not be covering graph AI. It's not kind of it's a course in itself, right? But in graph AI, what we do is we take entities, right? And it is like it's a representation where entities are connected to each other. That's why it's called a graph with with an edge, right? So these are two nodes of a graph. Okay, these are called nodes or four nodes of a graph, and the edges between the graph, this line connecting them, is the relationship between them, right? So that's like a graph AI, right? So it's representing a data in a graphical format, as a graph. That's what at a very high level graph AI is. So here, what are the relationship between these two entities? Joe Biden was born in Pennsylvania. Joe Biden's is the father of Hunter Biden. Joe Biden's spouse is Jill Biden, right? So why am I doing this? Because for a machine, if you ask a question, who is where was Joe Biden born, right? So then, okay, can I? Okay, I can write it here actually. Where was Joe Biden born? Okay, so this is a question, and without this format, uh, I think some of the approaches we discussed, right? We can divide this text into FAQs, right? And then we match it. Okay, which question is actually closest to this, and then we give the answer, right? But maybe if you already have this, right, and as Joe Biden born in Pennsylvania, father is Hunter Biden, right? Then do you agree that it might be easier where we can then compare this with these existing relationships and find out which relationship is trying to answer, or which it's not a relationship, it's actually an entity relationship pair, right? Or it's three things here. It's like entity one, entity two, and the relationship between them, right? So this group, I mean all these groups, one of these can probably answer it, right? How will you go about connecting this group to this text? Any ideas, any suggestions there? You understood my question? I'm saying Joe Biden born in Pennsylvania is a group, right? Two edges, one relationship, two entities, one relationship, right? And there are multiple groups like this from that article, right? Or maybe you convert. We will just do that exercise. Don't worry, where we'll convert things into nodes and articles, nodes and relationships. So once that is done, does this become easier? How will we then answer this question?
Yes.
How? Yeah. So
I mean,
how? Yeah.
so sir, once we do it, I mean to say, then it will be easier to answer the question.
Yeah, yeah, correct. So again, why I asked that question is because you see, conversational AI is like a really interesting field. Lot of developments happening, and so whatever solution I'm giving you, probably you might think and say, okay, maybe there is another solution I can try, right? So that's one benefit of this area, right? I personally find it to be very interesting because a lot of things can be done, a lot of tools and techniques available, right? So yeah, but the simple way to do it would be probably you have this bond in connect, as maybe the relationship itself becomes your intent, yeah, and then you take this relationship and compare it with your question. All these relationships are there, and your question you compare, okay, maybe which is the closest question to this intent, and that's it, right? So and you can probably, the entity here is the same as one of the entities here, so that's why it is matching. So this is my answer. Pennsylvania is my answer. Okay, does that make sense? I'm taking born in as an intent, father as an intent. See, again, it's strictly speaking, it's not an intent, it's a relationship. But for our earlier technique, we can use similar techniques here, right? That is one way. But as I said, multiple ways of doing it, right? And graph AI is really powerful. Lot of data sets, which if you don't use graph AI are very complex to handle, become really easy when you have graph AI on top of it. But again, just to clarify, we are not covering graph AI in this course. I just introduced it here. It's an interesting one. Please do refer online resources. I can point you towards it. You can connect offline, right? But yeah, this was just one important concept. What important concept we just studied is entity and its relationship, right? This format is the, if you organize the information in this format, the task of extracting information becomes easy, right? So we all are in agreement with that. We all are fine with that.
Yes, sir.
Yes.
Okay. Okay. Cool.
And sir, just to understand, you mentioned that we
Mhm.
need to initially we need to take the relationship as an entity, or in very crude way. I'm trying to understand.
I was just suggesting that maybe when you have a question incoming and you have just this data set stored with you, entity one, entity two, and relation, then how do you match which connection is my best answer, right? So one way to do it is relation is born in, is born is close to my question. If yes, then one tick box checked. The other question is the entity I am checking for Joe Biden in my question also present in that relationship? Joe Biden is there, then that gets checked, right? So two tick marks checked. Now you say, okay, then what is the answer? It is probably Pennsylvania. Okay, that is one thing. Yeah, yeah. Did I answer your question? Sorry, Swami.
Yes, sir. Thanks. Thanks.
Okay. So yeah, before we move forward to a concept of knowledge graph, I would like to show you something all very powerful. Have you seen this natural language API of Google?
No, sir.
Okay,
Sir.
I'll just open it. So it's part of Google's amazing tools, right? So natural language AI derive insights from, and why I'm showing you here, you will immediately understand. I'll show you an example. Derive insights from unstructured text using Google machine learning. Get insightful text analysis that extracts, analyzes, and stores text. Train high quality without a single line of code. Okay, that is not we are doing here. Okay, now this is what we are doing. Natural language understanding to apps with natural language API. Okay, again, we will not be using this API, but just to show you something which is what we just talked about, right? So this is something trying the API. Okay, trying the API. Google headquartered in the Mountain View. This address unveiled the new Android phone. Blah blah blah. Right. So if I click analyze, see the magic. Okay, I need to prove that I'm not a robot. Okay. So did you see they generated an output where it is showing you what all the entities are, right? It immediately identified. Okay. So why is this important? Once you have this output, can you do this, what we just saw in this slide, right? So Google headquartered in Mountain View, right? So do you see this connection happening? This is one entity, Google organization. Now Mountain View is a location in California, right? So you probably just found a relation, you found an entity relationship pair, right? Google, Mountain View, two nodes, and Edge is headquartered in. Do you agree?
Yes,
Yes.
sir. Yeah.
Okay. So again, life is not as simple as, I mean, I just showed a simple example. The one complexity here is this is Mountain View 1600 amphitheaters Parkway, Mountain View, California. The whole thing is there, right? Now this becomes not just Mountain View, but this whole thing becomes probably the node. So again, slight complications, but yeah, just you get the idea, right? So 1600 amphitheater. Okay, all this unveiled the new Android phone. So location, consumer good, Android. Sundar Pichai is a person. Phone is a consumer good. User is a person. CA. Okay. Do you see there are some things which got missed here? Okay. So do you see the CA is actually, I think, a zip code from California, correct? Now it is not able to identify it. What is it saying for 8 here? It is saying other. Salience is 0.05. What is the salience? It is telling you this. Salience shows importance or centrality of an entity to the entire document text. Ranges from 0 to 1, highly salient, right? So which is the most salient word in it actually here? It's till now what it is showing. I think Android and Sundar Pichai is 0.11. Google is 0.1918. So these are some of the salient words, right, or important words. But it is definitely missing out on this, right? It's also a location, but it is not able to find out, right? So why is it? So how can we make it identify? Any ideas? Any suggestions? Okay, so you understood my question, right? So this is a model. Google's model is already identifying a lot of things here, right? But it is not able to identify CA940430. So how do we typically go about it is, let me tell you the answer. So this is, we can tag this, right? We can annotate this data set, right? There are tools available, right? Where you can select this, right? Or you take this and then you tag it as a location, right? Or you can identify zip code, right? You can say, okay, for a zip code in USA, this is the type of pattern which a zip code is, and then you will see, I mean, then you can find it out, right? So those are some of the ways, right? But there can be other ways. Hope you got my point, right? Something is being missed, you test the output and you say, okay, looks like I'm not able to identify zip codes here, right? Okay, why is it? Okay, what is 16 here then? Okay, it's a number. It's not able to identify a zip code. It is just identifying it as a number, right? So that's one challenge here. So we kind of can identify a zip code by making that logic, like helping the machine with the logic to identify a zip code. So 2 letters followed by a zip code is probably a US state and its pin zip code, right? That's one of the logics you can kind of train the machine on. Then you will find out whatever is missing here is kind of whatever is missing here can be captured, right? Hope it is clear. Okay, but the idea behind showing this was, I'm not saying that you always use the Google's natural cloud API for doing it. I am now going to show you the way to do it on your own. So don't worry, we'll do it on our own. But an API is also a good, this is a good example of how you can generate entities out of text. Okay. Any questions? By the way, it has sentiment as well. Score range point. Okay, so I don't think this document was really negative or positive. So that's why I think the overall score is 0.2. This sentence is basically quite positive. It's saying 0.5 here. Score of the sentiment ranges from -1 to 1, very positive. So yeah, so it's probably 0.5. It's definitely very positive. Even these scores are really positive. Okay. So that's like the sentiment. Syntax gives you, okay, syntax is something, okay. Anybody who is familiar with whatever is written here, V mode, prep, and subj, I think you had NLP class. Did you like cover this, breaking this into the parts of speech, the word, text in that, sorry, words in a free text? Did you cover that? Sorry, am I going too fast? Let me know, please.
We covered actually lematizations, etc., removing the stop words.
Uh-huh. Okay.
I mean, sort of pre-processing.
Okay, so no worries. So you did cover all the important portions there, right? One thing which is, I mean, this what is indicating is, you can also in English. So okay, so this is probably, all of us probably studied in our high school, right? In an English sentence, there is a subject and an object, right? And there are verbs and other things. There are prepositions, there are nouns, right? And parts of speech, right? Which is basically what kind of, is this a noun? Is this a pronoun? That kind of thing, right? So we all studied in high school. And to be honest, and I mean, we speak English and we write English, but maybe we forgot some of these, probably, right? Understandable, we are not. But now is a time to kind of just refresh that knowledge. So in NLP, typically there are packages, NLTK for one, right? And Spacey. Have you used Spacey in the past? Spacey module in Python? Okay, surprised to know that nobody has used Spacey in the past.
No,
Spacey
sir.
module in
Mostly
Python.
we used NLTK.
Yeah, NLTK is very good. NLTK is like the basic. I mean, it's like one of the oldest and still very strong module in Python for natural language. But Spacey is also very powerful. So I would recommend you start using Spacey as well for a lot of NLP tasks. Okay, it's a very good module in Python. Okay, So yeah, so we will cover one exercise or do one exercise now where using Spacey we will assign these tags to each word, and using this, and once these tags are identified using some logic, which we will cover, we will understand. We will then divide this into this kind of structure you are seeing here. Joe Biden, born in Pennsylvania. Joe Biden, father of Hunter Biden, right? That's the whole idea, right? So that's the agenda. Any questions till now? We can actually try another thing here as well. You can change some text here. Maybe I can do. Uh, okay, let's identify this, or rather, I analyze this, right? So Reva University, it is finding as a location for sure, and salience is very important. Conversational AI is actually very important as well. So as you can see, this is 0.59 salience, which is very important. Reva University is 0.41, right? But again, it is able to identify it as a location, and conversational AI as one of the, it's not identifying it as an entity, right? So this is something we'll probably have to maybe train or do something to make it identify, right? Okay, so that was the discussion about conversational. I mean the entity extraction, entity and relationship, right? Hope it is clear. I'll move forward. Now there is this concept called knowledge graph. Uh, anybody who knows already about this? Any ideas? Can you share with us? Any and then knowledge. I mean, it's related to what we just covered: the entity and the relationship between them, entities and relations between them. So anybody who knows knowledge graph. By the way, we all uh, are using knowledge graph whenever we are searching Google, right? That's one suggestion, one hint for that. So please take a guess. What is a knowledge graph, or make a logical guess? Okay, so as I just showed an example where given a text, a paragraph, you could identify entities in it, and also you can have relationship between the entities, right? How are they connected, right? Now, if you do this for a very large data set, you basically end up with a large number of nodes. So A and C are the nodes here. So they can be Joe Biden and Hunter Biden. They are two nodes. And B is a relationship or edge, right? So this edge can have a label, or a relationship can have a label of father, or can have a label of born in, right? So this is like taking the information and representing it as nodes or entities, and edges, which is relationship, right? Now if you do it for a large data set, you end up with a lot of nodes, and all these nodes are connected to each other with a relationship. Now this whole thing becomes a graph. Don't you agree? So that is what is a knowledge graph.
Yes, sir.
Okay, so anybody has seen an example of a knowledge graph? Okay, let me show. If I search for a famous movie called Back to the Future, if I search for, can you tell me where is the knowledge graph example here in the search result? It's a famous movie from the 80s.
Is that on the right hand side? We are seeing some, uh, about the movie, and there are certain descriptions beneath that.
Yes, this is. I mean, this actually they are pulling from IMDb, public website, Rotten Tomato, and also what is it called, Wikipedia as well, right? But one example of a graph AI being at work here, right? And this knowledge graph at work is, I typed the movie name, right? But it immediately showed me all the actors in that movie. Okay, so how was it able to show? Because so if you take Michael J. Fox, so right in Google's knowledge graph, Back to the Future is one of the nodes, and there are so many other nodes which are connected to it saying Michael J. Fox acted in uh, Back to the Future, right? So it just extracted that information and it called it a cast and just showed you here, right? That's the one of the examples. So Swami, to your point also, the on the right hand side also it shows if you search for an actor, it will show some related actors as well, right? Sorry, Michael J. Fox. Okay, so so that's the other way around now. If you go down here, it is showing you all the movies in which Michael J. Fox has acted, right? So if I go back to the node entity diagram here, sorry, entity and the edges diagram. So Michael J. Fox becomes this node A, and all the no films which are where is acted will kind of spread out from this node with a relationship of acted in or actor, right? And that's where from that graph it has got this. And do you see how many other nodes Michael J. Fox has with the relationship acted or actor? 45 plus more, right? So this is a very straightforward application of the knowledge graph here, right? Hope you understand.
Yes, sir. Thank you.
Okay. Anybody else? Any suggestions? Any questions? Any views you have here?
But it has a very complex structure, right, sir? So example, the Michael
Mm-hmm.
is acted for a movie,
Mm-hmm.
and again in the movie, again as a primer, the first node, then has lot many other actors. Um, so there is a separate graph tree they construct for a movie. So this is the
Uh,
one way where we are thinking Michael is acted for around 45 movies, right? Uh,
mm-hmm.
mm, so in another case, when we searched for the Back to Future movie, then we saw all the other actors also in the town. So
Yeah.
there is again separate graph for a movie itself, right? Uh,
That's a great question, actually. Okay, sorry, you complete your question, please.
yeah, that's like different graph we do for each of the entity.
Okay, let
That's what we
me actually, yeah. So just to clarify, I think you have asked a very important question. Let me just create a new slide here so that I don't. Yeah. So for example, if I insert a shape, and this is maybe I'll just write it in short. Okay. My MJF, Michael J. Fox. Okay. And he has acted in these movies, not like this, the other way around. Sorry. Okay. By the way, sometimes these arrows can be directional. So what that means is if the relationship says acted in, and this is a movie name, then obviously you cannot say back to, and if this is like if this is like Back to the Future. By the way, this is one of my favorite movies during my school days as well. So yeah, Back to the Future, right? Or I'll just write the whole thing so that Back to the Future is the movie, this is the actor, right? So if my relationship here is text box, I would say acted in, right? If this relationship is actually just one, I mean the direction is flows from here to here. because you cannot say back to the future acted in MJF, right? That doesn't make sense, right? But if you if you want to make it bidirectional, then you can say, okay, maybe just change it to cast member or something like that, right? Then you can say, okay, back to the future cast member is MJF, right? Something like that, right? So to your question now, I think Santosh, you asked that question, right?
Yes, sir. Yeah.
Okay. So if I make it as act, let's keep it as acted, right? Now there will be a lot of these arrows. Let me just draw one more arrows here. Shared shapes. And maybe some other, maybe yes, so BTF2 is also another movie is acted, right? So all these this will be all, so all 45 films will be there as circles around it. Now to your question, we don't need a separate graph. It's just one huge knowledge graph, Santosh. So Back to the Future here has this one incoming kind of row, right? Or whatever arrow, right? Or whatever, maybe a bidirectional arrow. But it will also have these arrows, all these arrows coming in from elsewhere as well, maybe something going out as well. So maybe these all are actors. Then there might be an arrow where a director is being pointed to, right? And then there will be an arrow which points to an entity, and it can be a release date, which is 1984 or something, 1985, whatever, I don't remember. So there is no separate graph. There is one huge knowledge graph with like millions of relationships, right? So that's like that's the amount of data you're getting. I mean, looking at, right? So there is no separate thing here. You're
Okay.
if you are looking at Google Knowledge Graph, everything is kind of connected. Whatever connections are there.
Okay, sir. Got it. There is no
Okay.
constraint on number of incoming or
Yeah, yeah,
outgoing
yeah,
connection. Okay, it's
yeah,
just
yeah. Number of whatever is there. So I'm just saying it's not necessary that Michael J. Fox is related to maybe the president of maybe Singapore. Maybe there's no connection, right? So those nodes are lying separately, but they are still part of the main graph. Okay,
got it, sir.
okay.
Yeah.
So that's so just to show you. Sorry, any other question? So just to show you guys, let me knowledge. Sorry, knowledge graph size. Maybe Google. Okay, in fact, they have this generating specialized knowledge graphs. Okay, okay, apply for access. They don't give you access. I think you need to apply it. Okay, so what data do I need? You can feed this data to this particular. I'm just sharing, and just as a fun experiment, and also to understand. I'm sharing this here. Generating knowledge graphs. Okay, so it will generate knowledge graph for you. And by the way, we will not be generating knowledge graph as in graphical output. We'll just limit ourselves to the entity and relationship, because once you have that, then generating a graph is just a bunch of extra code, additional code using Python tools, which will just generate it and show it visually. So you can feed a set of text that contain digital text, OCR, okay, blah blah. That is not okay. The graph induction algorithm find terms relevant to corpus. Okay, so it does a very easy thing, right? So I mean, it makes your life very easy. You upload this text file which you have, and it will generate a graph with all these entities and the relationship between them. So definitely try this, how it looks. Okay, I also other thing I wanted to show was knowledge graph Wikipedia. Okay, do you see? So Santosh, to your question, see, this is one knowledge graph where you have so many nodes. I wish I can open it in a, maybe I can. Okay, so DBpedia is something where it is able to open it. As a subject, predicate, object, right? So another way of talking about these nodes are their subject. One of the entities is a subject of the sentence. The another is an object of the sentence, and this is the predicate. Okay. So Rome, Italy is the capital city of Italy. Italy is the capital city of Rome, right? So it is that's what RDF. It's called. So RDF is generally this format is called an RDF, and it's a triple. Three things are being stored here: the subject, predicate, and object. Okay. So Santosh, see this. Look at this knowledge graph. It's still not as big as Google's knowledge graph, but it is having so many nodes, and the connections are like they're almost hidden. There are so many of them.
Yes, sir. Yeah.
Okay. Okay. So yeah. So this is like a very powerful way of representing knowledge. I have seen in personally also, and I've read about it, is that a lot of data sets which are complex to analyze or take a lot of time to analyze when you use traditional methods like a SQL based analysis or something, when you move it into a graph DB or convert it into a graphical format, becomes really easy. Okay, so do try it on your own. Generate this knowledge graph of something using this. I mean, the article which I just link which I just shared also.
Yes, sir. Thank you, sir.
Okay, so let's come back to our slide. I will delete this slide now.
So in the previous slide, you have
Yeah,
mentioned about nodes, edges, and labels, right? What exactly are the labels here?
labels can be. So if you remember in the slide I was just talking about label. This is actually an image. I will show it here. Yeah. So born in is a label of this edge. Father is a label of its edge. Spouse is a label of this edge. Okay. So and then of course Joe Biden is the label of this node because that's what the node is called. So is that clear?
Yes. Thank you.
So knowledge graph should be clear. I have also given a good definition. I mean, there are many definitions. Knowledge graph, Wikipedia article itself you can read. IBM.com cloud learn knowledge graph, right? That's a good. So object, place, or person can be a node. An edge defines the relationship between the nodes. For example, a node could be a client like IBM, an agency like Ogilvy, and so on. Okay, so let's move to the exercise, I think. So extracting entity and relationship from text. So I have this link here, which I'll be sharing with you shortly. I really like this the way they have explained it. Right, I would request you to do that. I will be sharing a data set shortly. But before we do that, let's have some discussions on this. So if you see these two sentences, the 22-year-old recently won ATP Challenger tournament, right? And Nagal won the first set, right? Now, I was just talking about, I just showed you an example where Google makes your job easy. It Google API can generate entities and of course a relationship you can find between those entities, whatever text is, you can extract it. But how about let's do it ourselves, right? So whatever I have shown you till now, how do you think we can do this? We can extract, given a sentence or given a text, given a paragraph. Please let me know, share ideas on. Don't go to this blog just now. We'll go to it later. But given a text, how do you think we should go about extracting the nodes and the relationships? Any ideas?
So
Maybe we
from
have
the
a call.
sentence,
Yeah, yeah. Anyone can say one by one. We're fine with it.
Go
Go ahead.
ahead, Nur.
I have a very like, I
Yeah,
mean,
yeah. Please go ahead.
we
As I
can just
said, there are multiple ways of doing things here. This is a very interesting domain. So go ahead. Maybe whatever you suggested is also like one of the better ways of doing. So go ahead.
so we can extract all the nouns from the sentence and we can make them as notes. or entities, and like verbs and other stuff could be made as like labels, as you told, or the relationships. So something like that could be done to build knowledge graphs.
And that's a good approach at a high level for sure. Thank you. Yeah. So you can. So I think there was who else was saying that?
Santosh.
Yeah, I was also saying the same lines, like we'll extract kind of entities
Okay.
and build the knowledge.
Okay. So you see, extracting entity, we did see that parts of speech thing which I was just showing. I hope I still have it open actually. Okay, maybe Google NLP API. Okay. Just let's analyze this once. I am not a robot. Okay, so let's do categories. What is categories? Oh wow, it actually is also classifying it. It's like a zero-shot model, right? It's classifying the whole thing into internet and telecom, mobile and wireless categories. Okay, see a complete list of content categories. Oh wow, so these are all these labels which Google thinks anything can fall under. So yeah, this is a good source also for if you are trying to use a zero-shot model for doing a random classification, right? And you don't know what label should be there. Maybe this label can give you some idea. There are so many labels here. Do you see? Law and government, news, online communities. So yeah, interesting. So, but yeah, right now we are referring to. Yeah, what happened here? I how do I go back? I hope it doesn't block my IP by if I'm doing it too many times. Okay, so syntax. So yeah, so Santosh and I think Noor, good answer there. Google is a subject here, right? And Mountain View, it is saying it is an object, right? So it is at a high level correct. We are correct. We can identify using parts of speech which are the entities, but there are some practical issues there, as in the way English is written, and there are some complexities the way addresses are written, and many other things, that it is not as straightforward as just extracting maybe the subject and the object. But there are some ways, and the article which I will just be sharing with you in the chat covers that beautifully. So I would expect, like, I would request all of you to, there is no Google Colab there, but just take the code from there and we'll all will run it on a data set. I'll be sharing it. We'll take a small break after some time. And then after that, we'll come back and run it. I want everyone to run that because that's a very powerful technique where you're not using a natural language API here, but you're generating the relationship on your own by using that piece of code, and we'll understand that code a bit as well, right? So yeah, you're correct. This is the way to do it. I mean, by the way, this is called a tree. As it's a tree-based structure. As you can see, it has like a lot of elements which are connected to each other, right? And not going to too much detail here. This is definitely a very important portion in NLP, right? As a whole, where you have this parse tree of the sentence and the relationship between different words. Now we will use this logic, or rather these tags, to come up with our nodes and the relationship between them, right? So I think that's the next step we'll take. Let me share with you the article link. So hope I think last time almost all of us were doing Google on Google Colab, right? Anybody who's doing it on a standalone machine, that's fine with me as well. Am I audible?
Yes, sir. Yes, sir.
Okay. So everyone is doing on collab, or is there somebody who's doing on the machine as well, their laptop or desktop?
I'm doing it on my laptop.
Okay, Gatirishan. You have a GPU, Gatirishan?
No, sir, I don't have a GPU.
No worries. I don't think today you'll need a GPU, but I was just wondering if in future sessions, if we do for zero shot model, definitely GPU was required. Did it run slow for you?
Yeah, it was a bit slow, but yeah, it worked.
Okay, so in cases where a GPU is required, then I would request you to use a Google Colab as well, right? Just for
Sure,
running it. Okay.
sure.
So there is this other class I take for the MBA batch on deep learning, and there, yeah, we definitely can't survive without GPU. So there we start hitting that issue where GPU kind of the Google Colab starts giving you limits, right? The free version. So yeah, there are some challenges. Yeah, so no worries, we can try that. Whatever. I don't think we'll have a resource issue.
Sir, on a side note, can you
Yeah.
also guide us, how to use the proper accelerators like GPU, how to procure them, and because many a times we spend more time on in waiting for the code to run rather than tweaking the code or.
Yeah. That's very important. The good question. So I think. So are you asking about if you buy a laptop or get a laptop from the company, what kind of configuration it should have for a GPU? Is that what you're asking?
Yes, sir. And but more importantly, if I have an existing device, how to add external GPU if possible, or maybe buy something from Colab, which is more effective. All those things.
Yes, so okay, good question. See, like couple of years back, probably hardware would have been required because I think Google Colab and all were not very popular or were just coming up maybe 2-3 years back, right? I think Google Colab came like what 4 years back, not earlier than that, right? I have not seen it earlier than that. So yeah, so for that I would recommend try. I mean, there is this paid version of the Google Colab as well, right? And it's I think it's around. I have never used it, but I've heard other students, some of them have taken a monthly thing of around $10 or something. Not sure, just check it out. It's also very good having that. It gives you decent amount of very decent amount of GPU support, right? Now, if you have an existing system which supports buying GPU card, then go for it as well. That's also fine. But nowadays, these cloud providers like Google Colab, and even I think has anybody used Kaggle's cloud, sir? I mean Kaggle's platform as well for running the code. Any of you?
Yeah, we all tried, sir, in
Yes.
computer vision.
Yeah, that also has some limitations, right, in terms of GPU. But yeah,
30 hours. Yes.
so I think just explore the paid options because I think in some cases buying a machine with a high-end machine with a GPU might be costlier than paying like a recurring fee to Google Collaborate. That's my understanding of it. So
Yes, sir.
that's one thing. That's one suggestion I have. Okay, so let's take a 15 minutes break here, and I've already shared the thing. Just try it out. We'll discuss that in detail once we come back, and we'll also run it on a data set which I'll give you. Right now, I've just shared the link. We'll discuss it once we come back. Let's meet in another 15 minutes. Okay. Thank you.
Thank you, sir.